So table B1 lists the enthalpy or the latent heats for phase transitions that occur either at their atmospheric boiling or melting point temperatures, right? But there's going to be a lot of cases where we're going to deal with a phase transition that's at a different pressure or a different temperature than what's listed in table B1. So how can we deal with these sorts of phase transitions? Specifically, how can we calculate the enthalpy involved in them? So how can we what about phase transitions that occur not at TB or TM at P equals 1 ATM? Okay? How are we going to deal with that? All right? And so the tool we're going to use in order to deal with these kind of off phase diagram transitions is we're going to develop hypothetical process paths. So we're going to revisit the concept that we introduced towards the beginning of Chapter 8. Okay? And so here's the general idea for how you employ a hypothetical process path. So, general idea, calculating delta H or delta U for phase changes. Okay? So what you want to do is for your system, you're going to start at either some inlet conditions, so inlet temperature and inlet pressure, right, for some phase. Right, so if you're dealing with an open system, you're dealing with inlets. If you're dealing with a closed system, you're dealing with initial temperatures or pressures. Okay? But in any case, you're at some phase. Okay? And so the next thing you would do is you would calculate the delta H change from T inlet and P inlet to whatever the temperature and pressure are for the tabulated latent heat. So what I mean by that is if your phase transition occurs, let's say at 150 degrees and 3 atmospheres of pressure, right? But you start at 0 degrees Celsius and 1 atmosphere. What you would do, and table B1 lists the latent heat at a temperature of 100 degrees Celsius and 1 ATM. What you would do first is you would just integrate and calculate your delta H for heating up to that 100 degrees Celsius first, right? And then after that, once you get to the conditions of the latent heat, the temperature and pressure conditions, what you're going to do is you're going to add the delta H of the phase change, so that you add the enthalpy change that's involved from going from one phase to another. Once you phase change, then you're going to add the delta H of going from the tabulated conditions to whatever the outlet conditions are or the final conditions are. Okay? And so mathematically, your total enthalpy change would be equal to the integral of T inlet T tabulated of the heat capacity of the phase inlet. Then you add on the latent heat that's associated with the phase change T and P, and then after you phase change, you're going to integrate again using the heat capacity, but now the heat capacity that's associated with that new outlet phase. Alright? And so this is sort of an abstract concept, but we're going to get a lot of practice developing these hypothetical process paths, including in the next video.